right, so the problem that we're going to practice is this one. All right, so here we go. Do you know what to do to get started?
Factor it.
Yep, you gotta factor everything. So we're gonna factor completely. So the top factors how? How does x squared minus x minus 2 factor?
Well, Rusty, can you just show it?
I absolutely can, but you gotta be able to do this on your own.
Yeah.
We just unfoil it. We just unfoil it. And then on the bottom, we notice that we can take a 2 out. Yep, so if you can take something out, we always want to do that. So I'm going to go ahead and pull that 2 out. And then I got to keep the 2. But then what's left is x minus 2, x minus 3. And anytime I factor, I always do a quick check of foiling to make sure that I've done it correctly. Because if I factor wrong, then my picture is going to be wrong. Now, I notice that I have a cancellation. So my problem that is left is this. This is what I'm actually going to sketch. So what have I got here? What are some things you can tell me about this problem?
Wouldn't the vertical asymptote be 3?
It would, x equals 3. So make sure that you label it in your picture, and make sure that over here where it says what's the vertical asymptote, that you write x equals 3, because that's where the denominator is 0. All right, what else do I have in my picture?
You have a hole.
I do. Because I canceled, that's a guarantee that you're going to have a hole in the picture. And the hole is going to be at the x value you canceled out, which is 2. So then I can go back to my new problem here, my simplified problem in the box, and I can plug in 2. Plug in 2. So plugging in 2, it's going to give me 3 over 2 times 2 minus 3, or negative 1. So I got negative 3 halves, or negative 1 1/2. So I'm going to put a hole at 2 comma negative 1 1/2. All right, what else do I have? Right? You got a whole list of stuff there you have to find. You got your vertical asymptote and your hole taken care of. Where are your intercepts? How do I find my intercepts?
You put the zeros in.
Yep, I put the zeros in, so I'm going to get a couple more points. And for one of them, I'll let x be 0, and for the other one, I'll let y be 0. So if I put in 0 for x, I'm going to get 1 over 2 times negative 3, negative 1/6. So I'm going to plot that point. Zero, comma, negative 1/6. Now notice when I actually plot that point, it's on the y-axis, right? Which makes it the y-intercept. So that point is the y-intercept, and I know that because when I plotted it, I put it on the y-axis. Now, I'm going to let y be 0, and I like to think of that as 0 over 1, so that I can cross multiply here in my fraction. So 0 times anything is 0, and 1 times anything is itself. So it looks like my x-intercept is at -1, 0. That point is also called a 0. So on the answer sheet, or on the quiz paper there, I have called it a 0. That is the same as an x-intercept. All right, the next thing on the list there is we need an end behavior asymptote. Now, yep, it's y equals 1/2. Y equals 1/2. The end behavior asymptote can be horizontal, and in fact it will be horizontal whenever the x powers match. So when we have x squared over x squared, our end behavior asymptote is horizontal. It's y equals 1/2. We just box in the x squareds. 1x squared over 2x squared, 1/2. If the power on top is bigger, so if we had x cubed over x squared, something like that, then we would do our synthetic division and get a slant asymptote. We would get something like y equals 3x plus 5 or something like that. But as long as the powers match, we're going to get a horizontal end behavior asymptote. Now, in terms of the picture itself, we pretty much got what we need here now. So we can connect the dots. And when we connect the dots, hopefully you see this picture right here. You should see something else also that's only half the picture. Where's the other half?
On the top right.
Yep, right up here, opposite it. Now, I am going to use that picture to answer all of those limit questions. But before I erase all this, does anybody have a question about what's there, the picture, getting all that stuff for the picture? Okay, then let's use our picture to answer all of these other questions. All right, so to infinity, 0. I'm taking these right off of the quiz. They're going to be exactly the same. But of course the answers are going to be different because the picture will be different. These answers depend totally on what your picture looks like. Okay, here we go. So the first one says, find the limit as x approaches infinity. Where is x approaching infinity?
it be like the 3 with like the positive as the exponent?
Right out here, this is where x is approaching infinity. So you're going to follow your curve all the way to the right. X approaches infinity. This is infinity, clear out here. So as you take your curve off the right side of the page, what is happening to your y values? These are all y values. The limits are all y values. What is happening to your y values as you go farther to the right on that picture?
You get closer to the 1/2.
You do. So the answer is 1/2. And since you're getting closer to the 1/2 from the top, in other words, you're coming down toward the 1/2, we put a little plus sign there to indicate that we are coming in toward that asymptote from the top. Now, I'm going to skip that. Oh, go ahead.
If it's on the bottom, do we put the minus?
Yeah. Now, so I'm skipping down here to this one because this says exactly the same thing, only it says go to the left. Approach negative infinity. Go to the left. Well, as we follow the curve all the way to the left, isn't it still getting closer to 1/2?
Yeah.
But it's getting closer to 1/2 from the bottom. It's coming up from the bottom. Now, this one says, let x approach 0. Now, this is where x is 0, and you have a point there. When you have a point there, the answer is just your y coordinate. Remember, limits are y values. So if you're letting x be 0, y is going to be negative 1/6 because there is a point there. Do not mess that up, people. If there is a point at that x value, the answer is the y value, period. All right? X approaches 2. All right, let's come over here to our picture. Where x is 2, don't we have a point? I know it's open, but it's still a point. So what did I just get done saying? If you have a point, your limit is the y. So the answer is negative 3/2. So look down here. This is exactly the same thing. It says x approaches 2. So that's also negative 3/2. If you have a point there, it doesn't matter which side you're coming from. Don't mess around with it. If there's a point there, the answer is the y value. The limit is the y value. All right? Now we're approaching 3. Uh-oh, we do not have a point at 3. We have an asymptote at 3. As we approach a vertical asymptote, as you come toward it, you can't cross it, so you have two choices. It's like a roadblock, kids. You're either going to go down or you're going to go up. You don't have a choice. So in this case, we're saying, let's come at it from the left side, from the negative side. What is my curve doing as it approaches this asymptote from the left side? What's it doing?
It goes down.
It goes down, so negative infinity. When you approach an asymptote, when x is approaching an asymptote, when x is approaching an asymptote, you're either going to turn up or you're going to turn down. There's no other choice because you can't cross it. So what happens from the positive side or from the right side?
Goes up.
Goes up. All right, anybody have a question about any of those? Feel like you're gonna do better this time?
Yep.
Yeah.
All right, why don't you take a minute and put everything away except your quiz paper. Hopefully you printed one off. If not, you'll have to handwrite all this out. Did everybody print one off?
I can wrote.
Everybody's got it? All right, I'm just gonna put the problem on the board then. And you're gonna do it. Please put your notes away. This is honest. We're doing this by the book. Everybody ready? Got everything put away? Okay, make sure you don't have your notes out, guys. Make sure your notes are put away, everything's put away. And you're gonna do exactly what we just did. Answer exactly the same questions, but this is your function.